Distinguished ladies and gentlemen, good day. Please, today we begin our class, and we are going to begin with physics. Now, for the students that we have written mock exams with, we made promise that we shall begin the solutions online. So the first subject is physics. Look at the mock exam we did, and let's look at the solutions to those questions we discussed. Now we have about 60 questions, 1 to 60. So in this first video, we shall discuss the first 10, and then the next video we discuss the next 10. So please, if you have the question paper, you can follow the questions as we read and explain. Now the first question says a train with an initial velocity 20 meters per second is subjected to a uniform deceleration of 2 meters per second square. The time required to bring the train to a complete halt is, so from the questions we are given some data. A train with an initial velocity, so initial velocity, which is u, they say is 20 meters per second, is subjected to a uniform deceleration. Deceleration is opposite of acceleration, which always carries a negative value. So deceleration is 2 meters per second squared. Then the question says the time required to bring the train to a complete halt is, so we are looking for the time. So using the question that says v is equal to u plus or minus 80, which is the Newton's first equation of motion. So we use positive when the a is acceleration, and we use negative when the a is deceleration. So from this question, the a here is deceleration, so we take the minus, meaning we are going to use v is equal to u minus 80 because the a here is deceleration. So our u is 20, our deceleration is 2, and our final velocity, since they say to a complete halt, meaning to a complete stop, so meaning the final velocity is 0. Therefore, making t subject, I will have v plus 80 is equal to u, so that 80 is equal to u minus v. So making t subject, t is equal to u minus v over a. My u is 20, my v is 0, and my acceleration, which is deceleration, is 2. Then 20 minus 0 over 2 is 10 seconds rather, since it is time. So the answer is 10 seconds. And 10 seconds is option C. Option C. So the next question is question 2. Question 2 says a body which weighs 50 Newton in air displaces 3.5 kilograms of water when partially immersed in water. The question says calculate the upthrust on the body. Now, anytime we immerse a body in water and some amount of the water is displaced, what happens is the mass of the water displaced is equivalent to the mass of the body immersed in the water. So from this question, a body which weighs 50, meaning the weight of the body is 50 Newton, and this body displaces 3.5 kilograms of water. meaning the mass of water displaced is equal to 3.7 kilograms. And the mass of water displaced is the same as the mass of the body immersed in the water. So they say calculate the upthrust. We're looking for upthrust. Now the formula says upthrust is equal to weight of the body displaced, or weight of water displaced. So weight of the water displaced is our upthrust. And we know that weight is mass times acceleration due to gravity. And the mass of the water displaced, they say is 3.5 kilograms. So I have 3.5 multiplied by acceleration due to gravity is 10. So I have 37 Newton. That's my answer. So this is the upthrust on the body. And this is option A. Option A. Now question 2. Question 2 says, which of the following is not an application of expansion in metals? So we say the answer is option B, which is temperature control in an electric iron. Option B. Question 4. They say, which of the following does not affect frictional force? Which one does not affect frictional force? A, the relative velocity of the surfaces in contact. B, the color of the surfaces. C, the area of contact of the given surfaces. And D, the nature of the surfaces in contact. So among these, the one that does not affect frictional force is the color of the surfaces. Yes, color of the surfaces, which is option B, is the answer. Question 5. Question 5 is a calculation. So question 5, it says if a current of 4.6 ampere, current of 4.6 ampere was passed through a wire of resistance 6.5 ohms. The question says the potential difference across the wire is, so we're looking for potential difference across the wire. Now using the ohms formula, which says V is equal to IR, and our I is 4.6, our resistance is 6.5. So when we multiply 6.5 by 4.6, so let's see, 4.6 multiplied by 6.5, so we have 29.9 volts. That's our answer, 29.9 volts, and that is option C. Okay, question 6 says the different time rates of flow of liquids is due to A, cohesive force, B, adhesive force, C, viscous force, and D, surface tension. So the answer is C, viscous force. Yes, what brings about different rates in flow of liquids? For instance, through a pipe, the different rates is brought by the viscous force in the liquid, meaning liquids that have more viscosity flow slower than liquids that have liquids that have high viscosity flow slower, while liquids that have low viscosity flow faster. So it means the higher the viscosity, the lower the flow of the liquid. So the different time rates of flow of liquids or fluids is due to viscous force, which is option C. Now question 7. A figure is given and we have an object inside a fluid. So we have three forces. One is viscous force, 2 is upthrust force, and 3 is weight of the body. So this is viscous force, this is upthrust, and this is weight of the body inside liquid. So the question says, from the diagram above, at terminal velocity, meaning at a point where this object stands still inside the liquid, They say the three forces are related by the expression A, V plus U is equal to mg, B, mg plus V minus U is equal to 0, C, V minus U is equal to mg, and D, mg plus V is equal to U. Now, had it been this object remains on top of the water, then this means that U plus V or V plus U is greater than mg. If the object does not sink or enter into the water, meaning V plus U, the viscous force and the upthrust on this body is greater than the weight. That is why it didn't sink. It did not sink into the water. Now, if it goes to the bottom of the liquid, it means mg is greater than the summation of these two forces, meaning the weight is greater than the upthrust combined with the viscous force. But when this object remains in the middle of the liquid, meaning within the liquid, it means the viscous force plus the upthrust force is equal to the weight of the body. And this is option A. So the answer is option A. From the diagram above, a terminal velocity, which is V naught, the three forces are related by the expression V plus U is equal to mg. Viscous force plus upthrust is equal to the weight of the object inside the liquid. Then question 8. They say chemical energy is used to power which of the following? Like a Lange cell, electric cell, a dynamo, or a solar cell. So the answer is electric cell. Chemical energy is used to power electric cell. Dynamo does not use chemical energy, it uses mechanical energy. Solar cell uses solar energy. So the one that uses chemical energy is electric cell, which is option B. Then question 9. Which of the following is a semiconductor material? A, copper, B, silicon, C, steel, and D, iron. So the answer is silicon, because copper, steel, and iron, they are all conductors.